and it's just for curiosity. Anyone else in the phone? Okay.
What customer like, that's important for us. So that type of taste we need to make.
Okay, so if you're in a restaurant, you have to satisfy your customers. You're right. So that's why we do QA. So we do the same type of projects. We are so awesome in Java coding, and we have been doing it for, say, 20 years or 25 plus years. Still, we want to do a QA. I have seen many people saying QA is not needed. Maybe as a separate QA division is not needed, but when a product is produced, we definitely need a QA. Just to confirm, as you said, all the inputs are brought up correctly, so the requirements are satisfied, and we have a defect-free product. Have a successful delivery. The quality should be fine, and it is as per the business needs, as per our customers and stakeholders' need. Just for 20%. You are preparing for 1,000 persons, and you are preparing, say, 100 plus varieties. Just 1,000 people. What would you do?
Sample for different.
Have different people sampling different items. Okay, good. Why?
There's different tastes.
Exactly.
They may like some things.
Everybody has a different taste. Somebody might like it or somebody might not like it. And other thing is, you have to deliver everything fast. You have to deliver it on time. It's not like, okay, I'll deliver for 10% first, and the remaining 990 should wait for some more time. So you need the velocity, veracity. As you said, everybody has a different taste, and the quality should be always good because the ingredient is different times. So we need to ensure the quality, and we have a lot of volume. So the same. The testing is essential. The whatever testing we have doing traditionally is different with big data testing because we are not doing in the same old traditional way. We are following the basic principles of ensuring that the requirements are satisfied, the processing is done well, and the output is delivered fine, but it is different. It is big data. It's not for 20 recipes, 20 guests, not 5 recipes. Rather, it is like 1,000 recipes, and it is for 1,000 people. That's more. What are the challenges you see? Maybe before going to this slide, 20 people recipe and 1,000 people recipe. What are the challenges you think it is? Traditional QA with less amount of data and with more big data. What are the challenges you see? Timing, right?
Consistency of the data.
Consistency of the data. First thing is we have to understand the data. The data might not be the same. We will get a structured data, unstructured data, or semi-structured data. That understanding is required. Second thing is the technical and expertise and the coordination for bringing in the data. That is different. We need that. Third thing is the sentiment and emotions are different. As Raj mentioned, we are not only just capturing the tweeter data, but rather we are capturing the sensor data. So the emotions and sentiments of the data should be captured and validated. Fourth one is, as I said, we need to deliver everything on time. It's not the first batch one data, but all the data, all real-time data, all batch data should be quality assurance, and it should be delivered with the right output. And the last one is, it's so huge and it's so heterogeneous. It's not uniform, and it's not always 1,000 data or 10,000 data. It's like millions and billions of data, and always comes in different varieties, not in the common same varieties. The challenges of big data QA. If someone is not aware of QA, I want to tell you a little bit about QA first, before even introducing the big data QA process. Several varieties of QA testing. Functional testing is when you build out a system, you go through the code and check everything is working fine. That is unit testing. And then once you build a system, you just check whether the system is working as expected. That is system testing. And once you build out the system, you integrate with other systems and you check whether the end-to-end integration or the system speaks to each other very well. That is integration system. And once you have done the integration, you have to check whether all the other systems which are connected to this system are not affected. So you do a regression of the existing systems and check whether the existing portions work fine. That is regression testing. And the final one is the user acceptance testing. It's not as per the developer's understanding, not as per the QA's understanding, but as per what the external customer needs. So that is the user acceptance testing, what or how the external customer will work on the data or work on the application. Non-functional testing portion, we do security testing. We come up with a lot of data with respect to big data testing, or if you're in a product testing, like you talk to several type of products, several type of applications, you have to do a security testing to check we are not a threat. And then we have to check with respect to big data, a performance testing is required. We are bringing millions of data together to check whether the data processing works fine within the expected time. And then the reliability testing. The system is not breaking down with large number of data, and volume testing with more number of volume, whether it's working fine, and compliance testing, because we are going with the healthcare world or finance world and to check whether we meet the compliance data or not. So these are some of the non-functional testing. Here.
Is there automation in big data?
We have automation in big data. Coming to the testing cycle, most of you are from the IT background, so you always know what it is, but how it works is when a business requirement is provided, a QA person tries to extract the testing requirement, whether it's a functional testing or a non-functional testing, they extract the testing requirement, and based on the requirements, they just plan and strategize what kind of testing is required, when do we do it, who will do it, which division will do it, and then once it is done, they'll estimate and they'll schedule that how much hours is required, or how long do we have to do this testing, which testing should overlap the other cycle, or do we need multiple cycles of testing. So all those are done in test estimation and scheduling. And then once that is done, we'll go for the test designing. That's based on the test requirements we collect. We just prepare a test case which says what are the step-by-step process to do to achieve a test requirement. So you have to say, if you're doing a front-end application testing, you'll say, go ahead, log in, click this menu item. You will have a page 1. Just enter file data in the page 1 and save it and check whether the data is appearing in the SQL database. That's like a small testing requirement. The data should be appearing in the respective tables. And the data is what you enter, your name, your address, your SSN number, and check whether data is appearing. So this is test data, and what you do, the step-by-step process is called test design. And when you actually execute with the dummy data or your test data, so you will validate whether you're able to log in, whether you're able to move to that menu, whether you're able to enter all the fields, whether you're able to save. Once you save, whether the data is updated in the database. All those processes is called test execution. And if there are any issues in any point in time, then you raise a bug or a defect which says, hey, I'm not able to enter my SSN number. It's just allowing me, say, 5 characters. After that, this field is disabled. So that's a defect. So this is the process. So when a defect is raised, developers will fix it. It's a testing process. This is for normal testing, how a database testing works. So you're seeing here, right? This is one of our front-end screen, which has like large amount of data entered here. So either you manually enter, or you have an automation tool just to enter all these data, or you have a file which just gives all the data. So all these are the input data, and this is the source database which we need to validate. And once we enter the data, normally in a database testing, how it works is, so you're seeing the left side with small boxes, right? So this is the source. So when you enter the data, it comes from one of the source, and there is some business logic which says, hey, if you enter a value, say 1,000, then it should be multiplied by 3. If someone enters a value, say 900, then it should go to table number 3. So there are some business logic which will be done for database testing for every single data. There will be a logic for processing. Once that is processed, it will be sent to the target tables. So you have table 1, 2, 3, 4, and you process something with the table 1, 2, 3, 4 details and send it to table 4 and 5. So these business logics are called as transformation logics. The process values will be sent, and once the process value is sent, it goes to an output table. Either it will be a table to validate, or it will be a report to validate, or it will be a graph that is generated, or just a picture form which just denotes how it works. So our work in database testing is to check the data inputted is properly, and then it is processed properly with the required business values or the transformation logics. Once it is processed, it is sent to the output table, or it is sent to the output file with via transformation logic. This is a simple database testing, how it works. Here. Good. So this is a high-level big data testing process. It's kind of similar to the database testing. As I said, there is similarity between our traditional testing and big data testing, but it is a big data testing. It is a little bit different. So the extraction of data, as Raj mentioned, Scoop or Flume is used to extract the data from a flat file or an OS or a CMR, anything. So you extract the data, and the big data testing starts from here. Once you extract, you validate the data is extracted correctly in the staging file. So, for example, you can validate the number of records that are extracted, the type of data that is extracted, and the fields, the number of fields that are extracted, and to check is there any field left out with the value, why the data is not entered. So the testing starts from the extraction, and then next is the transformation. So you saw the transformation log. You can use any scripting language like Pig to transform the data, which transforms all the business logics, and then you can do some testing like sorting, filtering, and do some joins, and then update the data in other table. So you can do all those transformations and validate the transformation data here. Is output data. So once the data is extracted, transformed, then again, it has to be outputted. You will check the output data. Again, the simple testing is, was the data outputted, the data type, or the field level validations, or you can say get a range of number of people who are earning a salary between 100,000 and 150,000. It's like you get a 4 million data, and you can check whether you have inputted the 4 million data in your input file, whether that is the same number of data here you're seeing in the output file. You can check a range, or you can check a output data validation. This is like small examples. Output data is verified. We will load it in the data warehousing, like use any scripting language which your company uses or which you know, and then load the data in data warehousing. Here you will compare the staging records, the records that we inputted here in the extract data, right? You're seeing here this staging data. You will compare here, and you will verify for the data sync, whether all the expected data is synced from the staging file into data warehousing. So this is the fourth level of testing. Final one is reporting. Please, we'll have a separate reporting team, but if the testing team is expected to do reporting testing as well, then you can do a data analysis testing or any tabular reporting testing or any data mining testing. These are the 5 different types. So far we have identified where there is a necessity for testing, where testing is required, and one single person can be asked to test. All these are, as I said, we can have a separate reporting testing team, separate data warehousing testing team, or we can have one person asked to test all these. And there is manual testing as well as automation testing in both these areas. Manual is really tricky for big data, I know. Here on the phone.
Data testing is always testing them.
Almost similar to, but the way we do is a little different. Maybe if you are doing big data testing, you can add more points. So one of the person asked the question, is big data testing related to ETL testing? So we have one of the person here who is already doing big data testing. So he mentioned that along with the inserted data, we just validate the transformation data as well in big data testing. So that is again a separate portion of testing. Am I right? Okay. Moving on. So as I said, big data testing is really different from traditional testing, but it is not the traditional testing. It is a little different from the traditional black box testing we have. But the primary goals for big data testing is because we have a humongous data, there is a high possibility we can miss the data is not as per the quality, or the data is not complete. So we have to verify we are getting the data completely into our HDFS system. So the data completion is required, that validation is required. The next thing, as he mentioned, that data transformation should be correct in big data testing. So that is, and the data quality. So with respect to the output data, whatever we got in the data ingestion, whether that is outputted properly, that data quality assurance is also tested. Initially, traditionally, two main methods were used, and I know it sucks. We cannot do a sampling, and it is called a stare and compare method. So have two different Excel sheets, say two different monitors, enter all these data, stare and compare. It's one of the, what you can say, if I want to torture a person, I can ask him to do this stare and compare testing and ask him to validate millions of data. But this was one of the methods that was used using Excel sheets. Just compare billions of data. Easy, right? We can do that. The second one was the minus queries. So if you have two different tables, you can just write a logic and saying, hey, I entered the data in table 1, and I'm comparing the column F of table 1, which is transformed and outputted in table 20 in column H. So table 1's column F value and table 20's column H, if you minus, is 0, if the data is transformed correctly. So say in column 25,000, you have minus 100, then it means either the data is transformed incorrectly or one of the data is not ingested properly or not carried over. Correct.
Not processed.
Correct. Either not processed, transformed, or not even ingested, or it is not in the output file. So we can correct the defect from there. But again, it is a painful process. If you have millions of data, go through and check. And if you have so many issues, again, you run the minus query and check whether it works fine. Now the issue arises in 50 or 56,000 row. Then you run the query. So that was really, they had their own major flaws. So that's why people started developing big data testing related tools. And we found a few of them in the market, like Dr. Elephant or Query Search, and again, MR Unit, Jambune, and for performance testing, we have Sandstorm and few more tools in the market. So I want to talk more about the tools.
Yeah, well, for the overview of the quick QA part of it, and thanks for driving that. So what I would try to sum it up like space. It's not standardized the way regular traditional testings are done. We have very manual setup, manual testing, there's automation testing, there's performance testing, use load runner, use Selenium, you're happy, right? Here the world is changing a lot, and so the evolution of the tools. So there are various places, that's why we talked about Hive and Pig and everything, and as we were talking, the transformations, they have to be verified on when you're doing all those transformations, the processing part which I was saying. So you still go back to the same paradigm. You look at the storage where the data is stored properly and it's processed properly. As simple as that. Keep that simplicity as there. But to be able to do with all these different tools, every company, several projects, product companies are coming up with various tools, and there are various in the market already. But still nobody has the monopoly or the lead position. It's so scattered and evolving, and I expect that to continue as the core loop or big data itself is changing. How can these stabilize? So it's evolving space. There's a lot of interesting things happened. Many companies are doing. Dr. Elephant is there. LinkedIn is doing a lot of work in that. There is a project called Dr. Elephant. which they are doing a lot of work in that area. Hadoop WebJ is there, several of these projects. So we're not going to go in specifically any particular tools, but just wanted to share you at the concept level what we are and give you a glimpse of data world and things. I think I like the example which Hema has, like cooking for 10 people, 20 people versus 1,000 people. That really makes you think. And most of the questions you guys answered, yes, how different will be the sampling part and multiple people tasting. So I think that's the way you should think how the world changes. So that brings us to the conclusion of the session. I know we were a little over time. If you have any questions, you can reach out to us or contact us through email or any format. We have recorded this session too. Take on any questions.